Hi, my name is Sam Engel, co-founder of the Global Mental Calculators Association, and the organizer of Calculation League. This is my first attempt at making an instructional video, hopefully first of many. I'm going to start with addition here today, partially because it is simple and partially because I'm pretty good at it. I finished 5th place in addition in my first experience at the Mental Calculation World Cup, only behind 4 East Asian soroban competitors. So let me show you what that kind of addition speed looks like. Okay, that was the addition of 10 two-digit numbers. Both of those were about 2.5, maybe 2.55 seconds. In video, I'm going to outline some tips and one important principle that hopefully will help you improve your addition times, as well as talk about some of the distinctions between non-soroban addition and soroban addition. Okay, the main principle that I'm advising you to use is illustrated in this snippet, as well as related articles by Catherine Thibodeau that indicate that fast and unconscious automated counting procedures are an efficient way to do addition. The last sentence of this says these procedures could be limited to very small addition problems involving operands from 1 to 4 because rapid mental scanning of a numerical sequence could be impossible beyond the size of the focus of attention. So what this means is when you are adding a small number, you don't need to have it memorized necessarily, because you can so rapidly sort of envision the counting that there is no efficiency gain to try to memorize it. So for instance, if I ask you what 6 plus 2 is, you can immediately come to the conclusion that 6, 7, 8, 6 plus 2 is 8. In order to use that principle to add any number, not just numbers between 1 and 4, we need to know these number pairs here, numbers that paired add to 10. If we know these, then we can convert an addition of 6, 7, 8, or 9 into a subtraction of 1, 2, 3, or 4, which also involves a quick movement to the left on this imaginary number line. Here is an example. On the left column are 10 randomly generated one-digit numbers. They sum to 49, and this would be the steps of adding them up. Now, according to the previous principle, when the next sum is 6 or greater, what we're going to do in the ones column is subtract rather than add. So right here we are at 16 plus 7. We are going to, rather than add by 7, we are going to subtract by 3. It is easier to move 3 units than it is 7 units, so we're moving from 6 to 3. Now, when we alter to a subtraction rather than addition, we will automatically be adding 1 to the tens column unless the ones column subtraction results in creating a negative number. So from here, we have 6 down to 3, and it becomes 23. 23 plus 8, we're subtracting 2, adding 1 to the tens column, we get 31. Likewise, down here, we have 38 plus 8, so we are subtracting 2, moving up 1 here, so 46. The rest of them, are just, they're 5 or less, and we're just gauging an addition. Another example. 10 randomly generated numbers in the sum column. We're going to start with 8. 8 plus 5 is 13. 13 plus 9, we subtract 1 in the ones column, and then we add 1 in the tens, so we're at 22. 22 plus 3, we move from 2 to 5, so we have 25. 25 plus 4, we move from 5 to 9, 29. 29 plus 2, we move up to 1, carry 1, so we're 31. Now we're going to do 31 plus 6. We switch the 6 to a minus 4, which moves us back down to 7. And because we crossed under 30, we are not moving the tens digit up. We're really down to 27 and now up to 37. 37 plus 6, we move from 7 down to 3, add 1 in the tens column. 43 plus 7, subtract 3 minus 3 is 0. Add 1 in the tens column is 50. And then 50 plus 6, really, if the ones column has a 0 in it, we don't really need to engage in that movement of the number line, obviously. It just becomes 56. Want to add fast, you are going to have to work with multiple columns at one time. So here's an example using the sum of 10 two-digit numbers. They sum to 549. We now have a ones column, a tens column, and a hundreds column. Now in this example, I'm working with each of the digits to be added independently and to illustrate how that would be done. So we start with 35, we add 22. The ones digit goes up from 5 to 7. The tens digit goes up from 3 to 5. Both of them are moving 2 positions to the right on a number line. 57 plus 99. Okay, so the 9 means we're going to move down 1 on the ones column. When we move down 1 on the ones column, because we're doing a subtraction, we have to move up 1 on the tens column. But because we have another 9, we're going to move back down again 1. And then because we did a subtraction, we have to move up 1 in the next column. So we have a 1 in the hundreds column, 156. 156 plus 72, we add the 2 to the 6 and get 8. We move to the left 3 spots in the tens column, 5 to the 2. And because we move to the left, we have to move up 1 in the hundreds column, 228. 228 plus 17, 7 means we have to move to the left 3 in the ones column, moving to 8 from 8 to 5. Because we moved to the left, we have to add 1 to the tens column plus the 1 that we're from the 17. So now we're at 4, 245 plus 73. We're moving to the right 3 spots. We're going to move to the left 3 spots, and because we moved to the left, we're adding 1 in the hundreds column. So 245 plus 73 is 318, and so on. Here's another example where the formatting looks more similar to what you would probably envision in your mind, which is the tens and the ones digit columns written from left to right, and then the hundreds column separately. So if you're starting in the middle here, 286 plus 93, we are going to add 3 and then to the ones column and then move down 1 in the tens column. Because we're doing a subtraction, it moves up 1 in the hundreds. 379 plus 97, again 7, so we're subtracting by 3. Because we subtract, we move up 1 in the tens column, but because it's a 9, we move back down 1. Because we move down 1, we move up 1 in the hundreds column, and so on and so on. Okay, so I'm going to go over some practical tips for doing basic additions. First of all, don't overcomplicate it. The success at doing additions requires you to build up muscle memory, which requires you to engage in the same process over and over and over. Any sort of deviations will obstruct you from forming that muscle memory. So, for example, when you're scanning a column of numbers, don't skip over numbers looking down the column to try to find more convenient numbers. When you make it to the bottom of the column, go up to the top of the next column. Always scan top to bottom. I put minimal in parentheses because there are a couple slight deviations that I think are productive. One is always looking at the next 2 numbers, not just the next 1 number. For example, if the next 2 numbers are 56 and 44, it's not efficient to add 56 and then 44. You can just know that it's 100, but I wouldn't look more than 1 number ahead, and I would only use that in a very very minimally. The second thing is you don't have to go in order if it's not most efficient. For example, if it's 7 plus 2, you can add the 2 and get 9. But if you have a 2 and the next one's 7, it is okay to think of that in the reverse and think of that as 7 plus 2 and arrive at 9, rather than trying to use the 7 and subtract 3 from 2 and creating extra steps. Um, Second of all, subtraction practice is very important for doing additions, but it is natural for most people to find subtraction slightly more difficult. And if you're skeptical of this number line counting process, the fact that it is naturally more difficult to do subtraction, it is me pretty strong evidence that this is an efficient method. We are used to moving from left to right, and that is how addition works on the number line. Subtraction, when you reverse the process, it's a little bit less intuitive, and it takes more training. But subtraction will obviously help you in this process. Doing this process will make you better at subtraction, which could then help with other types of questions, for example, division and square roots. Addition, it's not very exciting, but it is a very efficient form of brain training. Developing your addition can make you better at so many other types of calculation. And if you find it frustrating to try to become faster or better at a task that involves very little complexity, Flash Anzan is very efficient for forcing your mind to adjust to a faster speed. And if you're not familiar with Flash Anzan is addition where the numbers flash on the screen. You pick the speed, you pick how many numbers, you pick the size of the numbers, and they flash at the speed on the screen at a given interval, and then you write the final answer at the end. Finally, so at the beginning, I indicated this was a non-soroban demonstration. Soroban users are able to move to more than two columns. I showed the one column example and the two column examples, but not more than two columns. It is almost unheard of for non-soroban competitors to use more than two columns. The only person I have seen do it efficiently is Wenzel Gruis, who is so extraordinarily talented that I'm not sure that exception is particularly meaningful. I think there are neuroscientific reasons why we can focus on two things sort of essentially instantaneously, but when you add in more than two, it becomes a problem. So while Soroban offers a visualization advantage in allowing competitors to do more than two columns at a time, it is questionable whether there is anything more than a minimal speed advantage. And what I mean by that is it's not clear to me that it allows a person to actually add one or two columns of numbers faster than they would be able to without the Soroban. And let me show you why. Here is Arjen at Paderborn in September 2024. He's in the process of doing a new standard addition world record for that software. It is the addition of 10 10-digit numbers, and this is his last question on that record attempt. So you can see he's adding 4 columns, and then 4 columns, and then 2 columns, and he finishes his 10 questions with 78.08 seconds. That was the addition of 10 10-digit numbers 5 times in 64 seconds using 2 columns by a non-soroban trained person. Uh, let's see how it stacks up to Aryan's world record attempt. Aryan obviously soroban trained. In that attempt, he was doing 4-4-2. I've also seen him do 3-3-4 while I'm using 2 columns. When you're going to make 3 passes to solve the 10-digit addition, you're going to do 27 total additions, whether you're going 3-3-4 or 4-4-2. You have to do 9 additions for every time you go from top to bottom. You have to, so he's moving 3 times from right to left, 27 total additions. Mine has 45 additions. His record attempt 0.289 seconds per addition, and my demonstration there 0.286. So, as I said earlier, I do believe soroban speed can be attained. However, the visualization, it seems to be implausible, very implausible, if not impossible. But you can end up being very fast doing 2 column addition without soroban training. I would recommend implementing the approaches in this video. These approaches they are implemented by soroban users. If you think of the soroban, they are moving beads very quickly to up and down, not right and left as in a number line, but it is more or less the same principle. And it's not. I do think, with the caveat that you can't do as many columns, the same speed can be obtained using this principle outlined here.